Let's do a question. Hard, of course. Recover a tree from pre-order traversal. Right. If you run a pre-order depth first search on the root of the binary tree, at each node in traversal we output d dashes, where d is the depth of the node. We output the value of this node. If the depth of the node is d, the depth of its intermediate child is d plus 1. Depth of the root node is 0. Right, so you do 1 minus 2 because that's level 1, and minus 3. It's pre-order traversal, which means it tries to go all the way. It prints everything. It should print 1, 2, 3, 4. So basically from the top to the bottom to the right. So 1, 2, 3, 4, 5, 6, 7. Here we should do 1, 2, 3, 4, 5, 6, 7. Alright, so how do we recover the depth? Well, I mean, if you do 1 minus 2 minus 3, since I see that the level here is still 2, that means I know it's a child of 2 still. Yeah. Isn't that kind of easy because you have minus 2 and you have minus 5? That means they belong to the same one. If you have minus 3, minus 4, I know they belong to the previous node that had a depth of 1. Same as there. But here. I know this belongs to node 1. I know this belongs to previous node of depth 2, which was this. I know this belongs to previous node of depth 2, which is this. I know this belongs to the previous node of depth 1, which is 4, 1. So I could keep a map of the depth. It will be into a node pointer. Tree node. Last. You know what we can do? We could use a string stream. I think this will work. I'll have to experiment though. Let's just return null. Hate how it's not right. Okay. You have a string stream traversal, input into the traversal and output to a number, to a string actually, to an integer. So let's say int n, and then cout n. So this should give me, in the first case, a 1. Yay. Yeah, the hard part is actually passing it, so it might be better if I just go through and for all the minus signs, I think it's always going to be positive. Yeah. For all the minus signs, just keep the depth. And okay, how do you actually pass it? What if I pass it into a char and then I just do a loop? So while char c, while c is equal to that, to ss that, and then at some point I'll reach a number which I don't want, so I actually want to put it back, so I can do ss dot, so string stream put back. I don't know, let's just do put back c. So here let's put it back, and then we can do ss, read it into n, and then print it out. So this should print out 2, hopefully. Yay, we get it 2. Okay, so that would work. Let's just for now focus on getting this loop correct. So that means going through and printing out the depth and a node. I don't know why they gave it like this, the input. It's just testing the string skills. They could have just gave the depth and the number. Is there a specific reason why they do it like this? Probably not. So while ss.empty, I think that will work. We could declare an n and a c. While this, and then put it back. Don't read this in. I do kind of want to print it out though. I also want to print out the depth, like that. Already buff, in avail. Okay, fair enough. I have a feeling I should be reading in the... doing this first. And then reading this. And then printing it out. So, yeah. That's correct. So you hit, for 1, you have 0. For 2, you have 1. 3 is depth 2. 4 is depth 2. 5 depth 1. 6 depth 2. 7 depth 2. Okay. Now all I have to do is put it in the map when I see it at that depth. So I can say last depth is equal to... Now, it depends whether... actually... I think that will work because if you have two different, so in this implementation, I'm replacing the previous one at a particular depth. So here, when I get to -6, -6, I replace -3 because I definitely won't be using -3 anymore. Because in between two nodes of the same depth, I would have encountered all the nodes in the subtree of the first node. With that depth. That's pre-order traversal. Like for example, 2 and 5. I would have encountered all the nodes under 2, so 2, 3, 4, before I start 5, which means I can replace -5 with -2. So I can say last depth is equal to a new node, new tree node, and we're given a constructor that takes in a value, and that's going to be n. Left and right can be left empty. I could probably, okay, these values go up to 1 and 1,000. We could say the depth starts at 1. And then we could have just a simple array containing up to, say, const int. So let's say static const int max. N is equal to, up to, number of nodes in the original tree is in the range 1 to 1,000. Oh wait, the node value. Number of nodes in the original tree is within the range 1 to 1,000, which means it's up to 1,000 nodes, which means the depth goes up to, since we're starting from 1, 1,000, right? So we need 1,001. So we can max n here. And we have a bunch of tree node array. So instead of a map, we could have nodes. Then we say the node at this particular depth. You know what? We don't actually need this array. We just say node at a particular depth is equal to a new tree node. And I'm pretty sure all of this will be null pointers to start off with. So we can say node at the depth is equal to a new tree node. Depth, of course, we only go up to 1,000. So at index 1,000, that's like 1,001 items into this array. So that's good. And then I could check that the parent node. So if the depth is not equal to 1. No, actually, just to make it a bit simpler, I could say that the node at depth 0 is equal to just a placeholder node and then do node at depth -1, so that'll work now. It's equal to dot left. Now it depends. It's a binary tree, so I have to check if the left, if there is a left child node. Just say tree node star parent is equal to node at depth -1. Now if the parent dot left is equal to node, then I want parents dot left is equal to my new node. Else the parent dot right is equal to the node at the depth. At the end, return the node at depth 1. Parent right. Nice. Yes, it seems to work. So what's the bound? We have 1,000 nodes. So what happens if we have one node? Should work, right? Yeah, okay, give that a go. Hoping that works. Yes, nice.